I'm a lot curious about machine learning. I would like to know more about it. Can you help me?
Yeah, just before getting started, just can you share a little of your background, which class you are, which syllabus you follow, what
I'm
makes you
in
more?
8th class. I follow the syllabus CBSE,
Okay,
but out of the syllabus, I'm curious about machine learning.
okay. So you have developed an interest after our first episode on Introduction to Data Science, right? So you saw the machine learning. So you have developed. You see, the machine learning, getting computers to act without being explicitly programmed, because we have not programmed the computer for very, very explicit. It's more into a general. Any kind of the data, the machine, the algorithm learns from the data in form of the training. We test with some portion of the data for the testing, and for at last, on the data we have split into the evaluation, right? Or the data for the evaluation, we deploy the data for into the our model for the final output. So let's get into what are the popular algorithms under the machine learning. You can see the screen, Troy. Can you see that? Can you see the screen of something like in the left hand side, supervised learning, unsupervised learning?
Yes, I can view the screen of the supervised learning and unsupervised learning.
Wonderful. So broadly, the machine learning is classified in two classes: supervised learning family and unsupervised learning family, right? So in the supervised learning, you can see these are the popular.
Can you give a brief explanation about supervised and
Uh,
unsupervised
oh, yeah, one sec. Yes, yeah, I will be using a software as I was talking, the TIPCO, the Statistica, the TIPCO Statistica, which happens to be one of the leader in data science, machine learning, and artificial intelligence as a platform. And the Statistica has named as a leader this the four times in a row uh, in a leadership position, right? So let me open the software.
learning? I can view the
Okay, wonderful. So this is the first interface of the software Statistica. As you can see, just although it is a very powerful tool, but it falls into the category of the no coding, low coding tool, right? So in order to perform from basic descriptive statistics to the predictive analytics, you need not to write a single line of the code uh, for various tasks and operations. So here we have just we need to pull out some of the regression data to get a sense of the structure and the characteristics of the data for a regression problem. So here I go to my open example. Under the open example, we have hundreds of inbuilt data sets are available for our own practice, right? So I will be pulling a data called poverty star, right? You can view my screen, Troy.
yes, I can view the screen.
Wonderful, right? So here, what you can see, one of the matrix kind of the structure. right? And this on the top of this, you follow my pointer. On the top of my screen, you can see 7p by 30c. The v denotes to variable. Variables denotes to the column. What we can see over here, this pop underscores chng, population change, right? Not employed. So these represents as the variables in the column. And what we see, like the Benton, Cannon, Carroll, right? The Scythian, Decal, Dyer. These are the county of the United States, like what we have in India, like the state, like the Maharashtra, Odisha, West Bengal, so on and so forth, right? And there are 30 rows, right? 30 rows are there, right? Which represents various county from United States of America. So what is the task in hand? Right, as we talked about what like the machine learning, artificial intelligence, right? The supervised learning, the larger purpose of all these advanced algorithms to build a predictive model or to do some kind of the forecasting, right? So here, what you observe here, all my data points falls into continuous in nature. These are numbers. 13.7 minus 0.8 not employed, you get number of unemployed. You can see the 400, 710 canon represents, right? pt poor pt poor is 19%, 26%, right? So these are the percentage. The pt poor, suppose I wanted to see the full view of the description of the data, I can go to the data and I can go to the all specs here, like PT poor, described as the percentage of families below the poverty line. So here, what is the problem we have in hand? The problem we have in hand is we wanted to build a predictive model in order to understand out of these 7 columns we have, out of the 7, the PT poor is my target, right? So I have a target variable in place. So it falls as a supervised learning, right? Because I have a target variables in form of the PT underscore poor. And once the target variable appears in the numbers, then it becomes a regression problem. Mind it, right? So all my variables are continuous in nature. My target variables are continuous in nature, right? So it becomes a regression problem. Fine. So this is the thing. So here is the task in these out of the 6 input or the independent variables. I wanted to identify what we say the parameter characterization, whether my population change or not employed or the tax rate or percentage having the phone, right? Percentage living in the rural or the age, which of the parameters is contributing to the percentage of people living below the poverty line. Fine. So this is the task I have in hand, right? And another task, once I build a model for my target variable PT poor, right? So next time I receive a data from the various county, let's assume like I will receive the data from Odisha. So very well, I can deploy the data into the model I have developed or the equation I have built, and I can get a prediction the percentage of the people living below the poverty line. So mind it, for a regression problem, that my target should be in continuous in nature. Fine, got it? How the my classification problem looks like? What is the structure of the data? How do I know whether it is a classification problem or it is a regression problem? So let me pull out one of the data sets. I go to the same data set. I will pull in a data called heart disease dot star. As recently we discussed, you can see on the top of the screen, the data set consists of 17 variables by 463C. As we discussed, C denotes to your uh, cases or the observations. So we have 463 rows and we have 17 variables of the column, right? So out of the 17, the column we have in hand, out of the 17, we have one variable called coronary heart disease, right? So this is my target variable. Since I have a target in place, it falls under the supervised learning, right? And you see the targets variables are labeled in the classes present, absent, so and so forth. So my target variables are labeled with classes. There are two classes are here in form of present and absent. So it becomes a classification problem, right? You understood? In case of the supervised learning, I should have a target variables in place. Once I have a target variable, if the target variables appears in numbers, right, then it will become a regression problem. If my target variables appears in classes or labeled with classes like present, absent, yes, no, good, bad, average, right, then it will be a classification problem. Another very frequently we deal with a data set, right, which comes in with a timestamp, right? So again, I go data set, this series, okay, series data set. So how many data set it consists, Troy? Can you make it out?
Uh,
You need to,
140
yeah, 144C as what the C denotes to? What
cases.
does this cases? Cases means this observation, right? What I can see here is January 1949, February 1949, March 1949, April 1949, so and so forth. So what you observe here from the last two data set, now this data set has been stamped with a time, right? These are the time, month of January 1949, and 144 cases means there is a 12 years of the data we have recorded, right? And these 112, this is the monthly passengers, right? Totals in thousand because this has been represented as a thousand. This is a 112,000 passengers has traveled in January 49 in an airlines, right? And what here our task is, we wanted to predict how many passengers will be traveling from your January 1961 and onwards, depending on like how many months you wanted to predict, like 12 months, 14 months, 16 months, right? You can do that, right? Since my target is in continuous in nature, and the data consists of a timestamp, then it becomes a time series regression problem. Are you getting me? Because earlier in the regression, all the things we had in common, we had a target variable that differentiate between the supervised learning and unsupervised learning family of the algorithm. And this differentiate between your classification and the regression problem, since I do have a the target variables in numbers and the classes. But here, one addition is that I do have the data with the timestamp also. So that becomes a time series regression problem. So this is the way we can differentiate the typical, the variety of the problems we have in hand. Now just we wanted to get a sense, what is the unsupervised learning, right? So in order to have this unsupervised learning, let me pull out a data set. I go to the similar way, open example from my inbuilt data set. I'm pulling a data of called cars, stuff. And what are the typically I have these unsupervised learning. Basically, I have under the unsupervised learning, I have something like your unsupervised learning, like K-means clustering, K-median, hierarchical clustering, expectation maximization, and so forth, right? And typical the problem under uh, these unsupervised learning is uh, would be like identifying the fact nodes, your whether it will be the spam mail, so and so forth, right? So these are the typical problem for the document analysis, so and so forth. So let's see how these data set look like for a unsupervised learning family of the algorithm like your file, similar way, open. I will open a data set called data set. I will do the cars, right? So what is the data set consist of, Troy?
Performances, price, acceleration, braking, handling, mileage.
The five, this data set consists of the five C, means five variables of the column we do have. And we have in the left-hand side, we have, you can see the Acura, Audi, BMW. This is the brand of the car we have, right? So from these variables, we have like the price, acceleration, braking, handling, mileage. We have to cluster the properties together in order to classify the, the type or the brand of the car, right? So suppose I will see the Acura, right? So suppose a customer visits to my showroom and he will ask, right? I am a price sensitive customer. I do have a budget of this much, right? So very well, you can recommend on the basis of this cluster, you can very well recommend him what kind of the car the customer would prefer. Like if the customer is a uh, has got a budget constraint, the salesman can recommend it's the budget car or it's the economic car you can recommend, right? On the basis of the clustering we see. And under this, like we have all these algorithm in Statistica, right? Under the data mining, we can go to the machine learning. Under the machine learning, we have the key nearest neighbors, right? So this is the clustering technique, right? And in addition to that, we have also under the statistics multivariate. I do have uh, the three type of the clustering, like the tree clustering, k-means clustering, and the two-way joining clustering. So all the advanced basic techniques of the clusterings available in Statistica for these unsupervised family of the algorithm. In addition to that, we have
All my queries have already been cleared.
okay. So now you are conceptually clear about what is the regression problem, what is the supervised learning family of algorithm, what are unsupervised learning family of algorithm, what are your dimensionality reduction technique, all you're clear?
Yes.
Okay. Can you recap like how we can differentiate a regression problem?
Differentiate regression problems by seeing that regression problems usually have